Okay, let's quickly look at two unknowns. Here's an IR spectrum for a compound. The one thing that jumps out immediately is this big peak. Now, where is this big peak? So anytime I give you an IR spectrum, it's going to have a table with the peak information. And so that's all this data right here. So this is the position of the peak in inverse centimeters. And this is the percent transmittance. And so there are several columns that show the position of the peak on the x-axis and then the intensity on the y-axis. So this big peak, this big dip is about, it says 17.7 there, and the percent transmittance is 4. Well, percent transmittance is a really low number. This is a strong absorbance peak. And 1717, that's around 1720. This is going to be a ketone, an aldehyde, or an acid, most likely. Now, a ketone will have just this peak. An aldehyde, we'd expect to have the smaller CH peaks at about 27 and 2800. And then a carboxylic acid ought to have that big OH absorbance in the ballpark of 3000. Well, we don't see really anything around 2700. I mean, whatever we see is super weak. So it's not an aldehyde. We certainly don't have some massive OH group over here. It is not an acid. This is a nice simple ketone. And apparently it's a ketone that does in fact have just below 3000. It has some sp3 CHs. Now, can I draw a structure based on this IR? No, I can't. All I can say is it's a ketone. So that's not very satisfying. Have we really identified the molecule? No, but we've used the IR to identify what type of molecule we have or the types of functional groups we have. So that's what we can do with IR, and that's pretty typical. How would we identify the exact molecule? Well, we need to use our other techniques, things like mass spectrometry or nuclear magnetic resonance spectroscopy to fill in the other details. Okay, let's see another spectrum. This is a very similar spectrum. Note that we have a big, strong peak. Where is that peak? That peak, that strong peak, 1709, that's around the position of a ketone, aldehyde, or acid. In this case, it's not an acid because there's no OH, big OH stretch, or around 3000. Now, it does give these two little peaks. Those peaks are in the 27-2800 region. Those are aldehyde peaks. They indicate the presence of this additional CH bond that we see in an aldehyde. So this is indeed an aldehyde. Furthermore, we can make some statements about this aldehyde. In, I think, virtually every other spectrum that we've seen a fairly large peak just short of 3000, and we said that those were our sp3 CHs. Oops. Sorry, sp3 CHs, but we don't have that strong signal here. Apparently, this is an aldehyde that doesn't have a lot of sp3 CHs in the molecule. Maybe it has something else. Maybe it has a benzene ring, but whatever it is, it doesn't have a whole lot of alkyl chain. So little alkyl chain. But this is almost certainly an aldehyde based on the strong peak at around 1720-ish. It's a little lower, 1709. And we do have these peaks in the 27-2800 region, and that indicates an aldehyde. Again, we can't identify exactly which aldehyde. We can just say that our molecule contains an aldehyde. And that's the type of information that you get from an IR spectrum.